Good morning, students. Let us consider an object moving in a straight line path. What type of motion is it having? It is said to have linear motion. But when an object moves along a circular path or along a circle, it is called circular motion. Then, what is meant by uniform circular motion? We are going to understand this term in today's module. Consider an athlete running along a rectangular track. Assume that the athlete runs at a uniform speed on the straight parts AB, BC, CD and DA of the rectangular track. Now, to be on the track, how many times does he change his direction of motion to complete one round? Yes, we can say that he changes his direction 4 times. Now, instead of a rectangular track, consider that the athlete runs on a hexagonal track A, B, C, D, E, F as shown in the diagram. If you count the sides of the hexagonal track, you can find that there are 6 sides. In this situation, how many times does he change his direction of motion to complete one round? 6 times. Starting from A, he changes his direction at B. Then again at C, he changes his direction. At D, E and F. And finally, he crosses A to reach the starting position. So in all, he changes his direction of motion 6 times to make a complete round on the hexagonal track. Now, if the track is not a hexagon but is a regular octagon. A regular octagon is nothing but a closed figure with 8 equal sides. The word regular tells that all the sides of the octagon will be equal. A regular octagon has 8 equal sides. To make one complete round, the athlete changes his direction of motion 8 times here. So when you have a rectangular track, he's changing his direction 4 times. If it is a hexagonal track, 6 times. And if it is an octagonal track, 8 times. So what can we conclude from all these examples? When the number of sides of the closed track is increasing, the number of times the athlete changes his direction of motion also will increase. What would happen to the shape of the track if we go on increasing the number of sides? Now the length of each side of the track will go on decreasing and finally becomes a point. And the shape of the track becomes a circle. We will have a circular track. Now, you can see the circular track where the athlete runs with uniform speed. In this case, how many times does the athlete change his direction of motion? At every instant along the circular track, he changes his direction of motion. He is moving with uniform speed but is changing his direction. Can we consider the motion of the athlete as accelerated motion? We have learnt about acceleration. We say that an object is accelerated when the magnitude of velocity changes or direction of motion changes or there is a change in both magnitude and direction. I'll repeat again. We say that an object is accelerated when the magnitude of the velocity changes or the direction of motion changes or there is a change in both magnitude and direction. In this example, the athlete is running along the track with uniform speed, but his direction of motion changes continuously. So, can we say that the motion of the athlete is accelerated motion? Yes, it is accelerated motion because he's changing his direction of motion at every instant of time when moving along a circular path. Now, take a small stone and a piece of thread. Tie the stone to one end of the thread and hold the thread at the other end with your hand. Now, try to move the stone to describe a circular path. Then, let the stone go by releasing the thread. You release the thread in your hand, the stone will go. In which direction does the stone move after it is released? The stone moves along a straight line tangential to the circular path. This is because once the stone is released, it continues to move along the direction it has been moving at that instant. At that particular instant, in whichever direction it is moving, in the same direction the stone will move when it is released. So repeat this activity by releasing the stone at different positions of the circular path. It always moves along the tangent drawn at that point where it is released. This shows that the direction of motion changed at every point when the stone was moving along the circular path. Also, we need a force to make an object move in a circle. Now, when a stone is tied to a thread and is rotated by a person in a circular path, then the pull of the thread is the force which makes the stone move in a circle. This pull is provided by the person holding the thread with his hand. The force which is needed to make an object travel in a circular path is called centripetal force. It is known as centripetal force. The force which is needed to make an object travel in a circular path is called centripetal force. In the case of satellite moving around the earth, the centripetal force is the force of gravity of the earth. Planets are also able to move around the sun due to the gravitational pull of the sun. Now, let us try to define what is uniform circular motion. When an object moves in a circular path with uniform speed, its motion is called uniform circular motion. I will repeat. When an object moves in a circular path with uniform speed, its motion is called uniform circular motion. If we consider the example of a satellite moving around the earth, The satellite moves around the Earth in a circular orbit with constant speed, but its velocity is not constant. Can you tell why? The direction of motion of the satellite changes continuously. So we say the motion of the satellite around the Earth is accelerated. Can you give one more example for uniform circular motion? The most common example which we can observe in our daily lives. The tip of the hands of a watch. The tip of the hands of the watch also show uniform circular motion. Now, we are going to know how to calculate the speed of a body in uniform circular motion. How do we calculate speed? We know that speed v is given by s by t, where s is the distance covered and t is the time taken. The distance covered s will be equal to the circumference of the circular path because the object is moving along a circular path. And the circumference of the circle is given by 2 pi r, where r is the radius of the circular path. So we get speed v as s by t, which is equal to 2 pi r by t. So the speed of a body in uniform circular motion is given by the formula 2 pi r by t. I think all of you have understood what is meant by uniform circular motion. Thank you.